Tap A fills the tub in 4 hours. Tap B fills the tub in 2 hours. How long does it take to fill the tub when tap A and B work together? This is the classic teamwork question. Let T be the time to fill the tub working together. In 1 hour, tap A can fill 1/4 of the tub. Recall that tap A fills the tub in 4 hours. So 4 hours later, 1/4 plus 1/4 plus 1/4 plus 1/4, we fill the tub completely. In 1 hour, tap B can fill 1/2 of the tub. Notice how tap B can fill the tub alone in 2 hours. So after 1 hour, it fills half, and then another hour later, it fills a half. Similarly, if there was another tap that perhaps this tap required 100 hours, then it could only fill very little of the tub, 1/100th of a tub in 1 hour. So notice how the number of hours goes on the denominator. So let's focus on tap A. We know that it can fill 1/4 in a single hour. So instead of a single hour, let's think about T hours later. Tap A can fill 1/4 times T, which is T over 4th of the tub. Similarly, tap B can fill 1/2 times T of the tub in T hours. Now remember that T is the official time to fill the tub working together. We're not quite sure what T is, but a certain amount of the tub is filled, this much from tap A, thank you tap A, and this much of work done is filled from tap B, thank you tap B. Working together, more things are filled up, so we're going to add these amounts of water together. So we have a fraction. Tap A can fill this amount of the tub, tap B can fill this amount of the tub. Now look at the pattern here. 1 hour tap A, 1/4, 1 hour tap B, 1/2. Similarly, in 1 hour, working together, tap A, tap B, instead of 1/4, 1/2, we have 1/T of the tub is filled. Because we're not quite sure how long it takes, the amount of time it takes for the tub to be filled. However, we know that in the same way how we copy down 2 hours becomes 1/2, 4 hours become 1/4, let's take this mystery number and simply go 1 over that number, which is 1/10 of the tub to be filled. And it makes sense because when you take that rate, when you take that amount and you multiply it by T hours later, which is the official finish time, this becomes T over T, which is equals to 1. So together, working together, it makes sense that the tub is completely and 100% filled. 1 means 100% filled. So let's try to put this together. We have a certain amount filled here. We have another certain amount filled here. And we know that tap A is responsible for this part. And we know that tap B is responsible for this amount. And we have an equal sign. Now the question is, T hours later, how much of the tub is filled? It's either this plus this, or it's equal to this part here, which is 1. So there we have it. We worked so hard to concentrate and figure out the equation to solve T. Once you have the equation, the rest is just algebra. It's not so hard. So let's multiply top and bottom by 2 here. So when you multiply by 2, you got a 2t here, and this becomes a 4. And let's multiply top and bottom by 4. So this becomes a 4 over 4. Let's multiply the whole thing by 4 to get rid of the denominator. So we get t plus 2t is equals to 4. 3t equals 4. Easy peasy pumpkin easy peasy. 4 divided by 3 is the time. So this is equals to 1 1/3 hours later, which is the same thing as 1.3 repeater hours. If you really want to be silly, you can always take the 0.3 repeater multiplied by 60 minutes just to get a better sense of how many minutes it would take. So if anyone wrote 1 hour and 20 minutes, they would also be correct. A professional painter can paint a room in 3 hours. As an untrained, sleep-deprived, and hangry novice, we'll call that hungry and angry, it takes you 9 hours to paint the room by yourself. How long does it take to paint the room together using teamwork? B. Why might this estimate be incorrect in real life?